see. Okay, there it is. There we go.
Awesome. Okay, let's start. But actually, before starting, let's wait a little. So in order to have this experience as enjoyable as possible, I want you to make sure that you are familiar with these technologies, with Node.js as a platform and with a web platform. So in Node.js, you don't need to know, complicated details, but Playwright test is a Node.js library, so you should be, comfortable installing libraries there. And for the web platform, you should be familiar with HTML, CSS, and JavaScript, this kind of stuff. Okay, now we are ready. So what is Playwright test? Well, Playwright test is a brand new product from the Playwright team. It is a batteries included test framework for end-to-end cross-browser web testing. So what are these batteries? Well, first of all, we have out-of-the-box TypeScript support. This is big because you don't need to set up any build steps or any transpilation steps to write TypeScript and then interpret as JavaScript. So this all happens out of the box. You just author your test in TypeScript and it works. Next, we have parallel execution out of the box, and it just works. You don't need to do anything special. It's just there for you. Next, of course, we are cross-browser testing framework. So we have multiple browsers, and we have multiple different features, such as snapshots and fixtures and many more. And we have also time travel debugging. And we will actually cover it later today in this talk. And last but not least, Playwright test is open source and free, now and forever. Okay, so today's talk's purpose is to give you, to introduce you to the Playwright test, and we have a small agenda for it. First, we'll get started and touch it a little. Then we'll talk about fixtures and what is it and how do I use it. We'll show different ways to configure a Playwright test and talk about artifacts management. And finally, we'll talk about the Playwright tracing, which is a time travel debugging. So with this, actually, let's get started. And the best way to get started with a new technology is actually try it out. So I'll just hop right into my terminal. And I'll start from scratch, and I'll create a demo folder here, and I'll initialize everything. I will initialize a new npm project here. I will initialize a new Git repository here, and I'll copy some git ignore that I have handy here. I'll add everything, and I'll commit it as staging, the very first commit to my repo. Okay, so now I am ready to start using Playwright test. And the first thing I do is install it with npm install at playwright/test. So Playwright test is just a node module. It has just a fancy name with a Playwright namespace because it is a part of a Playwright family. And here we have one big difference right away from Playwright. We don't install browsers right at this moment. So Playwright test comes as a library, and the next thing I need to do is to have npx playwright install to actually download all the browsers. In my case, though, no browsers were downloaded because, well, Playwright test is equally smart as Playwright library, so it caches the browsers at the same location on my machine. So this is really fast this time. With this, I am actually ready to go coding right away. And, well, usually on my demos, I use Vim, but this time we'll actually use VS Code and author a test in TypeScript. Oof, this is small font. Let me bump the size a little to 24 at least. Okay, so I hope you can see my screen clear enough. And first thing I do is import test. No, I want test and expect from Playwright test. Now I'm ready to go and write my test. So it will be a very simple one. And this is a test function that I pass as a test body. Now in Playwright test, I can destructure page as part of the arguments. And now I can use this page as just a Playwright page to do things like go to, for example. And I have all the other completion here. And I can navigate to my page. Next, I can click a button. And I happen to know that on this website, there is this visible link that has text docs. And after I click this link, I want to just assert the page URL. So this is the URL that should be there. So a few things to mention here. So if you are familiar with CSS, you might say that there is no such thing in CSS as a visible pseudo class. Well, yes, because this is a pseudo classes that are added by Playwright. So you can actually assert elements to be visible. Same thing with hash text. There is no hash text in CSS. This is a pseudo class added by Playwright. Okay, now I'm actually ready to go back and run the test. So to run the test, I use npx playwright test. And what this does, it starts the Chromium browser, starts this test. And well, it completes pretty fast for me. So this is already very cool, and this was easy to start. So let me just commit everything. What's this feed? This is my first test. But actually, I want to have it on and running on bots, on CI, on every commit. So let's do just this. I'll go to my GitHub and quickly create a new repository here. So now I have a URL I can copy, and I'll add origin with this URL, and I'll push it. Okay. So now I have this repository with my single test. I can look at it. And I'm going to use this actions feature of GitHub to actually deploy some bot infrastructure, testing infrastructure for my repository. Well, this is really easy to do too. I'll just do GitHub workflows directory. And I'll have this tests.yaml file. Now I have a small scaffolding here. And this is a very typical scaffolding for any GitHub actions that actually use Node. So it doesn't do much. It checks out the repository, sets up Node, and installs all the dependencies. Now, in case of Playwright test, I will also have 3 more calls. So first, I'll do npx playwright install deps. Next, I'll install all the browsers. So this first line will install all the dependencies for my browsers. The second line, install all the browsers themselves to the GitHub virtual machine. And finally, I'll just run all my tests. Okay, let's edit and push to our repository. Awesome. So now here I should have a new workflow. Here it is, and it's doing its thing. While it's doing its thing, I want to show you a few more cool features of the Playwright test. So first of all, Playwright test is a cross-browser testing library, testing framework out of the box. So we can run all tests across all browsers right away. And this is as simple as this with a browser all flag. And we can see that it runs the same test in Chromium, in Firefox, and in WebKit, and it actually works everywhere. Now, the other cool flag here is headed, and this will launch my tests in a headful manner. So this is important. Before we didn't see any windows popping up because all the execution by default is happening in headless mode. And finally, I want to demonstrate you that Playwright test is actually parallel by default. So we have this fancy repeat each command, which will run my test 20 times, actually each test 20 times. This comes handy when we debug flakies. For now, I will just launch it and show you that it starts 6 workers, and all of them launch in Chromiums, and these Chromiums are downloading and running things. So as one test concludes, the new one is getting started. So there are 6 workers and they are really processing the queue. Now, I think it takes usually roughly about 30 seconds, and this time it was 19 seconds, really quickly. And if I don't want to have them in parallel, I can always have them as a single worker. And this way we'll see that it's actually way slower. So by having parallel by default, we are saving a lot of time to our testers. Yeah, it's way slower. Okay, so let's see. So our tests, this is our tests back on CI. They concluded, so we are happy. And with this, let's go back to our presentation. Okay, recap. What did we just see? So first we saw Playwright test installation. So it was easy. It's just 2 commands. You install Playwright test and you install browsers as a follow-up. Next, we came up with a very simple test. It's just 3 lines of code, and we were taking advantage of this page given to us by Playwright test. And finally, we used Playwright CLI command test to run all the tests here. Okay. However, we did not stop here because we even used GitHub Actions, a really small and short one, to deploy our cross-browser tests to an Ubuntu machine. And it successfully ran there, which is really cool. Okay, so now we touched the Playwright test, and it was not exhausting in any way. And I think at this point we are ready to go and, oh yes, this is a satisfying green check mark, to go and learn about fixtures and magical fixtures, how we call them. Okay, so in fact, we are already using fixtures even without knowing it. So for this, let me bring up this test that we came up with. And let's focus on the very first line here. So here we have a page, and this page is actually a fixture. So this is a fixture that's provided to us by Playwright test. And the page fixture in particular is a fully isolated Playwright page. So if I have many tests, each of them will get the page object, and all of them will be different and fully independent from each other. And by destructuring this page in the test arguments, this is actually how I use these fixtures. So there are more that are very handy in test authoring. For example, context. So context fixture gives me an isolated Playwright context, which comes handy if I do multi-page tests. Next one is a browser name. So browser name just lets me know about the name of the browser that's running this test and which has been used in this page. It can be either Chromium, Firefox, or WebKit, which are actually all the modern browsing engines. And we also have an isMobile fixture that lets us know as a test authors if we are running inside a mobile viewport or mobile browser or not. There are many more fixtures that you can use here, but I'll stop just right here. So this is how we use fixtures. This concept of fixtures is actually borrowed from PyTest. I don't know any other JavaScript testing framework that has this concept implemented. With these fixtures, we can actually run your tests in parallel by default, because each fixture creates a fully isolated and configurable environment for each test. And Playwright test also comes with many ready-to-use fixtures like we've seen and like we will see in future. You can actually create your own fixtures, and we encourage you to do so instead of using before each and after each hooks. Because this way you can organize tests semantically instead of by environment like you have to do with these hooks. And also fixtures are very performant in a way, because fixtures are not initialized unless they are used by test. So if, for example, you have a test that doesn't use a page, then the page is not even getting opened. And as reported by some of our clients who were doing migrations from hooks to fixtures, fixtures are 20% less code, which is just easier to manage and less bugs. Now, in this talk, we are not going to deep dive into fixtures creation, but you can actually read more about this in our documentation. For us, we'll move on to configuration. And there are 3 different levels of Playwright configuration that you can do. So first, there is a global configuration that is done via a configuration file. Next, there is a granular configuration that is done via test.use. And finally, we'll talk about data-driven configuration. Okay, so let's start with configuration file. So in Playwright test, configuration file can be either JavaScript, and in this case it's playwright.config.js, or TypeScript. And in this case, it has a .ts extension. So for the sake of this demo, and actually I would recommend using TypeScript everywhere, because if you have a TypeScript configuration file and you use Visual Studio Code to edit it, then you will have a really nice auto-completion suggestions everywhere. I'll actually show you this. So with this, yes, let's open configuration file. So empty configuration file is very much a valid configuration file. And this is a boilerplate for the TypeScript configuration. Let's quickly go over the lines here. So first thing we do in our configuration is importing a type, which is a Playwright test configuration. Next, we declare a config, which is a Playwright test config. And we'll keep it empty for now. And finally, we export it so that Playwright test knows, how to read it. Okay, now there's a bunch of different values that we can put inside this configuration. And let's start with the first ones. That's called runner configuration. So runner configuration is a bunch of options that you can specify to control how Playwright test behaves. You can put global setup here, you can put global teardown here, and you can specify reporter. And by default, we use list reporter. And this is what you saw with these check marks next to each test as we were passing by. But we have actually many more reporters. For example, we have first-party reporters like dot, list, and JSON, and even JUnit. And we have a reporters API that could be used to create third-party reporters. And there is, for example, an experimental Allure Playwright reporter. Okay, let's move on. So after this global configuration, there come projects. So a project in Playwright test is just a configuration that is used to run your test. Now, you might have multiple projects, thus multiple configurations. And if you have one test and multiple configurations, then your test will be run multiple times, once for each configuration. So this time, we'll have just one project here. And when we configure a project, we can specify such things as a project name, which is trivial. We can also specify amount of retries that we use to retry a test. So if your test fails, first time, how much time do we retry it until we give up? By default, we don't retry anything, so feel free to change this to 2, for example. And you can also specify such thing as a timeout per test, which is amount of time we wait until it actually times out. So this is all pretty clear, I think. And the last part here is actually interesting. This is a use block that holds all the fixtures configuration. Now, you can change different values here, and I want to focus here. You can pick a browser, for example. Instead of browser name, you can say WebKit. And to show you how it actually works, I want to highlight on it and bring a simple test right to this configuration file. Now, on the right, we have this page fixture. And we know this is a fixture, and this is how you are supposed to use it. You destructure it from arguments. Now, it turns out this page fixture actually depends on this browser name. So if I have a browser name set to Chromium, then my page will be a Chromium page. If, however, I change browser name to WebKit, my page will be a WebKit page. And this way, using this use block, I can use configuration features to configure my page behavior. So there are many different features you can use for configuration, and there are at least 2 dozens of them here. And these all come bundled out of the box with Playwright test. And features are actually a very powerful concept. And the reason they are powerful is that you can not only configure them in your Playwright configuration file, but also you can have a more granular feature configuration, which is either per file or per test suite. So to demonstrate this, let's say you have a france.spec.ts file that happen to have all the tests related to France region. Now, inside this spec file, if I put test.use as the very first line, or the second line actually, then all the tests below here will run in this Paris time zone, for example. Now, for example, if I actually want to have some subset of these tests that also verify the light color scheme, then I can have a test suite called light theme here. And inside this test suite, I can put another test.use that sets a color scheme fixture. Now, the test inside this test suite will be running with the color scheme set to light and also in a Europe/Paris time zone, which is very nice. And of course, if I want to have a dark theme, I can go and continue this way. And this is how you actually configure fixtures. And this way you have basically immense control over your environment across projects, across files, and across your test suites. So next thing here that I want to touch on is called data-driven tests. So this is something that comes up regularly in our Slack channel. So I want to address it. So consider you have a urls.json file that has a bunch of URLs that you want to make sure don't time out for your website. So how do I make use of this data and generate a bunch of tests of this data? Well, let's see. So I will open check urls.spec.ts. And the first thing I will do here is actually require my URLs. Now I will just iterate over these URLs one by one. And for each URL, I'll just declare a test. Now, if my URL times out, this test will time out, and I will know that something is wrong. Otherwise, it will succeed, which is good enough for my example. Now, one thing to mention is that test titles have to be different here. Actually, in fact, if they're equal, if you forget to make sure that test titles are different, Playwright test will be very unhappy and will not let you run this. So this is because debugging tests with the same title is almost impossible. So usually if you have a data-driven test, make sure you have some key here to differentiate between different tests. Okay, so this was a quite extensive learning session of different capability configuration and fixtures. Let's use some of this to run our test on an iPhone. So for this, I'll jump back to my terminal. And yes, we'll start with playwright.config.ts file. So we'll do everything test config as we described before. And finally, export default config here. Okay, so I won't have any test runner options. I'll just have projects right away. And I want to keep my Chromium project. So I'll have Chromium here, and it will use a Chromium browser. So this is straightforward. But now I want to have an iPhone project. So how do I get one? Well, it turns out it is really simple. So Playwright test comes with a bunch of devices, and these devices are fixtures, could be used as fixtures. So I can just pass as this iPhone 12 Pro as a use, and I'll end up running a test under iPhone configuration. But if I want to add more fixtures here, I'll just have to, destructure the iPhone inside the use block. And this will be iPhone that also forces the light color theme. I don't need any light color theme here. I'll just keep it as this. Oh yes, and I promised to demonstrate you the fancy autocomplete here. So unfortunately, it crops half of the text for me here. But if I just command space here, I get all the different fixtures that I can configure for my project. Okay, let's close this and give it a try. I'll just run all my tests. So this should launch two. Yes, it launched two workers for me. One is a Chromium one, and the other one is an iPhone. And for some reason, it takes some time for iPhone to complete. Let me actually run it with a 5-second timeout so that we see what's going on. Okay, so yes, so the iPhone test is timing out for some reason, but it tells me which line doesn't work. So it says, aha, page click, I was waiting for this selector and I failed to wait for it. Cool. Well, I will use this opportunity to actually debug this test using Playwright Inspector. So I want to say pw debug equals 1 before running my tests. And finally, I want to just run on the iPhone project here. So what this does, it launches everything headed, and it shows me this Playwright Inspector UI. So here on the left is my iPhone. Here on the right, my test. And my test is paused on line 4. So I can step over. Okay, I already see what's going on here. And now we are on a page click action, and we are waiting for the selector, and it's not there. And of course, it's not there because it's hidden. You see, there is no docs on this page. It's hidden in this sidebar menu. So what I can do, I can just use this Explore button. And with Explore mode, when I hover over things in this Playwright Inspector, it will give me different selectors. So what I'm going to do, I will just hover over this button and I will click on it so that this selector is copied to this field. Now I can just copy the selector and modify my test slightly. So before clicking docs, I won't click this hot dog. So this is almost perfect, but this is not gonna work on Chromium. So what I want to do here is to use the isMobile fixture and to do this only on iPhone. Cool. Let's run this and make sure that things work. Okay, it worked. I'll commit everything. What is test? iPhone tests. And I push to my repository. Okay, so this is nice. Let's get back to the presentation. We succeeded here. So what did we just see? It was really easy for us to set up an iPhone, right? It's just 2 lines. One is to import devices, and the second one is to use this iPhone 12 Pro in the use block in project configuration. Okay, so this was easy. Next, oops, there is some latency. Yes, next we use the isMobile fixture to fix our test. Wasn't hard at all, but we actually had a small debugging session to figure out what are we supposed to click and how to fix this test on iPhone. And we did so launching tests with a pwdebug environment variable, and actually launching only one test for the iPhone project. And this gave up this kind of a UI with the Playwright inspector on the left and the iPhone view on the right. Okay, so this was all very cool, but we should say that we were lucky. And we were lucky because we had this failure locally. It was reproducible for us locally. So we could use this Playwright inspector tool to debug it locally and actually to fix it. Now, what should we do if this kind of failure happens on CI? Okay, so this naturally brings us to test artifacts or artifact management. So test artifacts is, what is it? It's a byproduct of test running that helps us debug test failures. So this is something we can store after each test has failed so that we can do post-mortem later on. In Playwright test, all artifacts are stored by default in test results folder. And we have 3 types of artifacts. So first one is called screenshots. And this is an easy one. So every time your test fails or just passes, we can take a screenshot of the page. So nothing fancy here. Second one is called videos. And this lets us record the full flow of the video of the test, how it was passing. And finally, we have this traces thing that we don't know what it is yet, but we'll discuss it later today. So by default, Playwright test does not collect any test artifacts. So we have to configure it so that it collects something. Now let's see how do we do it. So here I have a small Playwright configuration. And we've seen this a few times already. And I want to focus on a few things here. So first, we have these 2 things like retries and use. Now, usually we have retries and use inside a project, but this time we have them on the top level. And this means that all the projects down the line will inherit these options that we put here. So all the projects will have retries equal to 2, and all projects will have this kind of fixtures configuration block there. Now, this is how we set up artifacts collection. And this is actually a recommended setup that we have here on screen. So we configure screenshots to be taken only on failure. We don't collect any videos. And we don't do this because tracing is actually a superior technology to video recording. So we configure traces to be recorded whenever the test fails and upon its first retry. Nevertheless, let's go over the different configuration values for these artifacts. So for screenshots, we have just 3 values we can pass here. It's on, off, and only on failure. And on means take a screenshot after each test. Off means don't take any screenshots, and this is a default. And only on failure means take a screenshot of the page whenever the test fails. And this is actually the recommended way. Now, video artifacts. Now, video has on and off, again, like screenshots do. And it also has a fancy retain on failure thing. So retain on failure means we will record videos for all the test runs, but we will remove them later on, keeping only the ones that we offer failed tests. So this way you have a consistent behavior, but it takes a lot of resources to record and store videos. And finally, we have on first retry, which records a video only when we do the first retry of the test. Well, as I said, we don't recommend enabling videos because tracing is nicer, way nicer. And the tracing artifacts has exactly the same properties as videos. You can turn it on or off, and you can retain it on failure the same way as you do with videos, and you can have it on the first retry. And this is what we recommend everybody using. Okay, so now we know how to configure trace artifacts. The last thing we need to do is to upload them from our CI so that we can download it. And turns out it is really easy to do, at least on GitHub Actions. So this is a GitHub action we wrote like 30 minutes ago to run our test. Turns out I just add these 5 lines here, and it uploads this test results folder to CI so that I can download it later after the test run. Really easy. And with this, we are finally ready to know what Playwright tracing is and why we don't recommend enabling videos. So this is the most exciting part of this talk, probably, tracing. So Playwright tracing is a technology that consists of 2 parts. So the first part is a trace.zip files. So trace.zip is a portable file format that consists of stores all kind of information about the Playwright scripts. It has Playwright actions that were performed. It has all the Playwright events that were fired. It has DOM snapshots for every action. It has screenshots. It also has network log of all the requests that were happening during actions. It also has a console log. And to consume all of these goodies, we have a trace viewer, which is a GUI tool to explore trace files. Now, trace viewer is actually bundled by default with both Playwright test and Playwright library. So you don't need anything else. You can just record a trace, and you've just seen how easy it is, and use trace viewer to run it. So let me actually demonstrate you. Oh, yes, before we go to the demonstration, the Playwright tracing is actually what some might call time travel debugging. But we think that Playwright tracing is good enough for us. Okay, so now I want to demo trace viewer to you. And my demo will be a little bit fancy. I'll use a CodeGen to generate the first script. And this will be CodeGen. I'll save it to just a JS file, and I'll navigate to github.com. This is it. So CodeGen is this Playwright tool that lets me generate scripts. So here on the right, I have script that's been generated as I go. So first thing I do, I want to go here. Oh, yes, Microsoft Playwright. And I will click some issues, and I'll search for Electron, and I'll click the first one, and I'll check what I have here. It's good enough snippet. So let's close it. Awesome. Let's check that we have, yes, we have it. and it has a huge snippet. Now I will go to configuration file, and I'll enable tracing for my tests. Easy, right? I'll enable it just for everything so that I have it collected. And finally, I'll just run this spec file. Oh, I don't need it for everything. I just want for Chromium. Oh, yes, it completed in 8 seconds. It takes a while. Awesome. So now I should have a test results folder. Yes, I have it. And inside this test results, and this is gh test chromium, we have a trace.zip file. So I'll use npx playwright show trace command, and I'll use test results trace.zip. And this brings up a trace viewer UI to me. So let's look around. So first, at the very top, we have a timeline. And I can scrub over this timeline to see actually how the page load is happening. So we see, this is a WebGL, it's spinning this globe, and then it navigated to somewhere, and then I typed electron here and navigated. Awesome. So here we also have actions that are aligned with these screenshots. And this list of all actions is on the left-hand side. And I can just go over the sections one by one. And for each action in the middle of the screen, I have a DOM snapshot. And sometimes, for example, here, you can see a red dot, or here as well. So this red dot is a place where Playwright will click. And also you have this, this is very clear on GoTo. For each action, you have actually 3 snapshots. You have the one that's relevant to the action. You have the one that's before, and before we navigated, we had a bold blank. And after, this is the state of the page after the action actually concluded. So then we navigated from the main page to the Playwright page. So this happens for everything. For fill might be a little tiny for you, but here you might or might not see. I'll zoom in a little. There is no text here, and we have text here. And you see, I can actually select text and then scroll the page because this is a real DOM snapshot. I think CSS animations work here. There is no JavaScript though. All JavaScript is disabled. But other than that, it's a real DOM. I can actually even right-click and inspect it and use DevTools to explore this DOM so I can see whatever this page has inside. And finally, on the right-hand side here, we have some meta information about the action. So for example, what we have here, click. We have the name of the action that we have all the arguments that were passed, and we have all the log here. We can also see all the console, and for example, for the initial load, we had some console messages, and we can explore all the network. For example, you can see that initial navigation and the subsequent navigation had a lot of network requests. And then occasionally we had some. Well, this is a rich application, so you never know when it does network requests. And you can actually expand this network request and see some information inside of it. So, and this is Trace Viewer. So let's go back to our presentation. So we just saw how we can open Trace Viewer, and we learned what we can see in the Trace Viewer UI. Now, however, I want to show you how we actually can use this Trace Viewer to do a post-mortem of some failure that happened on the CI. And to do so, we'll use this issue. Remember the iPhone issue? We had a test, the very first one, that didn't work on an iPhone. And we fixed it with a Playwright inspector locally. Now I have a demo run of exactly the same issue that was happening for me on the CI. So this is our timeout. I was waiting for a selector, trying to click this button and didn't work out. So my tests failed. I have this unsatisfying red cross. And I uploaded my artifacts so I can easily download them. Let's do this. Okay. So I downloaded and I have now this trace file inside my downloads. Let's use it. Oops, npx playwright show trace. And then we have downloads. Tests should work iPhone trace.zip. Awesome. So this opens this already familiar UI to us, which doesn't have many actions because our script is tiny, right? It's just a go to and a click. And this click, we see that the action was interrupted because it was waiting for selector and it never concluded. So how do I, well, already from here, I can see that, oh, I'll actually show you. So we'll get this selector and we will try to find it. I'll open DevTools. Oops, I'll get this console. And we'll get our focus inside this DOM snapshot. And I'll try to use playwright.dollar to query for this selector. And indeed, it doesn't query. However, if I remove visible from here, it does find one. And I can actually even reveal it in elements panel. And I can see it right near my navigation button. So actually now I know that I want to click this hot dog button again. So how do I get a nice selector for it? Well, it turns out I can use this playwright object again. I just want to have playwright.selector and I pass $0 in here. And what this does, it generates a selector for a currently selected element in elements panel. And we have that button selected. So it generated this selector for me. And this is exactly the same selector that we had with Playwright Inspector when we were fixing it locally. And so this is what we would do if we didn't have a local reproduction. And this is how actually you can use Trace Viewer with traces to debug failures on the CI. Okay, so recap what we just see. We saw that we can right-click inspect to open DevTools on DOM snapshot, and we can use actually playwright.selector to generate a selector. And this concludes our today's talk. So I hope you enjoyed it as much as I did. If there is one conclusion we can get from this whole story is that web testing can actually be fun. So with tracing, you can debug failures that happen on CI. With parallel execution, you can have, you don't have to